Welcome to Raaonline. I am Dr. Sudakshina, Professor of Anatomy. I am going to talk about bony orbit today. We will go through a demonstration of the bony orbit in the PPT, and then we will be demonstrating the bony orbit in the dry specimen or the skull. So coming to the bony orbit, the orbit are pyramidal shaped cavities which are present in the human skull, and it lodges the eye, and also along with that it lodges a lot of other structures also. So we will come to that in the contents of the orbit. Prior to that, we will first learn the structure of the orbit, exactly what is the shape of the orbit and what are the bones which form the orbit. Now if you look over here, this is one of the orbit which has been shown, and this is the nasal aperture. So this is a normofrontalis view in which we are seeing the orbit, and you can see the orbital opening is directed towards the face. So this becomes the base or the orbital rim, and the apex of the orbit is directed posterior medially and it is inwards. So the apex is posterior medial and it is inside, and the base is opening on the face. Now this orbit is a pyramidal shaped structure which has four boundaries. It has a roof, it has a floor, it has a medial wall, and it has a lateral wall. So the orbit is a pyramidal shaped structure with a base which is called the orbital rim, and the base is hollow which opens onto the face. It has an apex which is directed posterior medially, and it has four sides. What are the four sides? It has a roof, it has a floor, it has a medial wall and lateral wall. So in the orbit, we will be studying about the bones which are forming the orbit before we come to the other features. So now let's see the orbit which is hand drawn over here. So you can see that there are some bones which are surrounding the orbit which will also participate in forming each wall of the orbit. So here we can see the roof, you can see the medial wall, you can see the floor, and you can see the lateral wall of the orbit. So coming to the case. Now why we have to study the orbit? Now orbital fracture is quite common. Usually the orbital fracture occurs in the floor of the orbit or the medial wall. Now medial wall of the orbit is the weakest wall of the orbit, whereas the lateral wall of the orbit is the strongest of the orbit. The fractures of the orbit floor, orbital floor, which is quite common, can involve the maxillary sinus, because I will be telling you each boundary of the orbit and what is it separating what from. So it can lead to a lot of sinusitis and other problems. So this is the clinical aspect. So now let's come to each boundary. Before that, let's introduce the topic in the notes. So we have the orbit as the cone-shaped structures which are immediately inferior to the anterior aspect of the cranial cavity. So if we see that this is the orbit, if you see in this picture, so definitely this structure is immediately inferior to the cranial cavity. So the cranial cavity is above that. So the anterior cranial fossa is being separated from the orbit, right? So because it is immediately inferior to the cranial cavity, the anterior aspect. So that's why the anterior cranial fossa is separated from the orbit. Now it has a apex, so I have already told you, and which is directed posterior medially. It has a base which is placed on the face and it is wide, and it is lying just below the anterior cranial fossa. That I have told you already. So now coming to the bones which form the orbit. Now if we see the orbit, if you see these are the two orbits, if we tell, okay, the medial wall of the orbit are lying parallel to each other, but the lateral wall of the orbit is sloping and forming a 90-degree angle with each other. So this lateral wall will form a 90-degree angle with this lateral wall. This will be 45 degrees. So this 45, 45, whereas to each it will be 90 degrees angle of the each lateral wall. So medial walls are parallel to each other of the orbit, whereas the lateral walls are sloping backwards and forming an angle of about 90 degrees with each other. Coming to the bones which form the orbit, you have the maxilla, then zygomatic bone, the frontal bone, the ethmoid bone, the lacrimal bone, sphenoid and palatine bone, which has very minimal contribution. So these are the bones which form the orbit. So we come as maxilla, zygomatic, frontal, ethmoid, lacrimal, sphenoid and palatine bones. Now each wall of the orbit will be having contribution from these bones. So we will come as each wall of the orbit. Now the apex of the orbit has one foramen which is called the optic foramen. So let's go back and see the apex of the orbit. Yes, so this is the apex of the orbit, or you can see over here also this is the apex of the orbit, and it has one foramen which is the optic foramen. Now this foramen is between the lesser wing and the body of the sphenoid, and that's the foramen. We will come to the structures which are passing through the foramens of the orbit also. So now we start with the orbital rim. So I already introduced this term to you. What is this orbital rim? The base of the orbit, which are cavities, which are pyramidal shaped cavities or cone shaped cavities, which are opening onto the face, forms a rim where it opens onto the face, and this orbital rim is being actually bounded by some bones. So superiorly you have the frontal bone. So if you see, so you can get superiorly the frontal bone. Then you have medially, you have the frontal and also the maxilla, the frontal process of maxilla. Basically, this is more of the frontal process of maxilla medially. Inferiorly, you have the maxilla and the zygomatic bone, and laterally, you have the zygomatic. So more inferiorly, you have the maxilla and zygomatic a little bit. Laterally, it is more of a zygomatic bone, the frontal process of zygomatic and the zygomatic process of frontal bone. So this all forms the orbital rim.